Ratios without a graphing calculator. This is the second straight assignment that is set to be a tutorial for you to use your yellow TI 84 Plus classroom graphing calculator. Now we don't have those right now, thus we're going to do what we can without it. And for that, you're going to see on the right to have your simplifying fractions calculator is going to be especially helpful today. But also, you'll notice that there's this notes and PowerPoint link. Some of you use this often, others of you probably didn't even know it was here. I'm going to show you in this link a specific slide that's very helpful today. It says, a ratio comparing two numbers a and b can be written in one of three forms. A over b with a fraction bar, or a colon b, or a and the word to b. A ratio should always be written in simplest form, which is why we have our simplest form calculator up on the right. With that, let's dive right into it and look at number one. Write the ratio as a fraction in simplest form, 18 colon 18. Well, right off the bat, if we use this calculator, you will see what you might already hopefully know, which is that any number over itself always equals 1, because we can divide the top and bottom by whatever number we have. We get 1 over 1, which is 1. So the first one is a rare problem that has no technical fraction as the simplified form. It just has a whole number, or an integer. In this case, 1. And notice how, in addition to giving a nice going green complement, it also has a little notes down here, which are helpful. 5 to 20. So 5 to 20 means the first number 5 always goes on top, and 20 goes on bottom. And notice it wants us to write this in a fraction. Even though it gives it to us with a 2 in between, it wants this fraction of 1/4. So make sure when you write these in, you're using your little slash next to the right shift key and typing it in as a fraction. Number 3, 25 colon 100. So we're going to have it be 25 over 100. Again, the first number is always on top. Second number is always on bottom. And what do you know? We've got 1/4 yet again. And the next one is the same kind of idea, only once again, 9 and 3, we're going to have both be able to be divided by a integer that they share as a factor, meaning we're going to get a whole number, because we can divide both the top and bottom by 3. 3 over 1, which equals 3. So this is another one. Don't put 3 over 1. If you do, you'll get it wrong. Just put in 3. Okay. And the next one, it says all bold and underline as a fraction, so don't forget that. Now, technically the mixed number is 1 2/3, but for this one, leave it as an improper. Leave it as 5 over 3. I have no idea if it will accept the mixed number or not. It just wants you to practice reducing in general and converting ratios to fractions. So there you go. Number 6, we're going to use all three forms of the ratios that we discussed in that PowerPoint slide. And we want to make sure that we have the reduced form in all three forms. Simplest form, all three forms as a ratio. So this 2 over 3, I'm going to type as a simplified fraction with a colon in between and with the word 2. Now some people always ask, do I put a space? Do I not put a space? It really doesn't matter. You can put no space, or you can put so many spaces that you can no longer even see the words on the screen. Either way, I will prove to you right now, it will accept it. Either way, even though it looks very weird. See? 2 to 3. All right, number 7. Same exact thing. We've got our 30 over 5. That reduces to positive 6. So here we need to remember that if we don't have a fraction, we can still put any number into a fraction by putting it over 1, just as it says down here on the right. So don't do that for the fraction, but do it for the other two. And here I'll use no space for this one to show you that that also works. Awesome blossom with extra awesome. 8, pretty straightforward. It's going to spit out a fraction that we use for all three, 3/4. So I've got the fraction, I've got the colon, and I've got the oscopy. Just kidding. It's a bad joke there. All right, 8 down, 2 to go. We're flying through this one. Just getting used to our tools here that'll help us when we start doing more complicated algebra, geometry, and other problems later on in the year. Order the ratios from least to greatest. Okay, this is very helpful. We are not great as humans at comparing fractions. It's just how it is. Fractions are more difficult to compare than decimals. Why? Because we use decimals for money all the time. All the time. But fractions, you don't often go to a store and be like, all right, here's 1/20th of a coin. This is 3/35 worth of a coin. No, we use decimals for that. So in order to best compare ratios, my advice is to always turn them into a decimal and then compare those decimals because you're used to comparing decimals with money. And here's what I mean. So 12 out of 3, I'm going to type that in. 12 out of, I said 3, but 13. 12 out of 13. And then we've got 1 out of 13 and 5 out of 13. These are much easier to compare technically because they're all over 13. So really we just have to compare our numerators. But the decimal form still works. This is like 38 cents. This is like a little over 7 cents. And this is 92 cents. 92 is more than 38, which is more than 7. So we can put it in, what's the least to greatest? So 1 to 5 to 12. And this really comes in handy with the next one. Because now we're doing 2 over 7, 12 over 7, and 3 over 10. So we've got 2 over 7, say 12 over 7, I believe. And I think it said 3 over 10. Let's check. 2 over 7, 12 over 7, 3 over 10. Yep. So this is 30 cents, $1.71, and 28.5 cents. So these two are close, but 30 cents is still more than 28 cents. And notice this is 30 cents, not 3 cents. 3 cents would be 0.03. If you are ever confused, you can just compare these. Like if I'm going to make this 28 cents, 28, there we go, cents, that's 2 decimal places. So then you can just add this extra 0. Now it's much easier to see, oh, I'm comparing 28 to 30, not 28 to 3. Very helpful. So then our answer from least to greatest is going to be 2 7s, 3 10s, and 12 7s. Not thrown off at all by the 3 different versions of the ratio. Very, very simple, straightforward, using our calculators that you can leave up every lesson. We'll use them for some, not for others, but it's just nice to have them up in case you need them. And we got 100%. Took us very slightly less than 8 minutes. This whole video is going to be less than 10 minutes. I deeply look forward to the day when I could return to my classroom and teach you the graphing calculator version of this. But until then, these resources will help you not only with this assignment, but with every additional assignment where you have to simplify fractions or convert decimals to fractions as well, like we still have up there from the last assignment. Much love, best wishes with your whole day, and until next time, it's been an honor and pleasure being your teacher. Bye-bye.